Hello everyone, today I'm watching Space Elevator, Science Fiction or the Future of Mankind by Kurzgesagt. I know nothing about this, so let's just get right into it.
It's hard to get to space. As much as we all wish there were an easy and affordable way to see our planet floating in the dark, right now, the only way is to become an astronaut or a billionaire. But there is a...
Or you could just watch the live feed from the International Space Station. I'm pretty sure there is one.
concept that might make it possible while serving as the starting point for the exploration of the universe, the space elevator. How exactly does it work? To understand how a space elevator will get us into space, we must first understand what an orbit is. Being in orbit basically means falling towards something but moving fast enough to miss.
When he says space elevator, I imagine just a straight line going straight to space. But I'm quite sure that wouldn't work because that sounds extremely stupid, and if anything hits that, it would be destroyed completely. So,
miss.
Yeah.
If you throw a ball on Earth, it makes an arc through the air and then hits the ground.
Yeah, that's called
In
gravity.
space, gravity makes you move much the same way, but if you move sideways fast enough, the curvature of the Earth makes the ground fall away beneath you as fast as gravity pulls you towards it. So to enter Earth's orbit, rockets have to go up and sideways fast. By contrast, a space elevator taps into energy from the Earth's rotation to get the cargo going fast. Imagine a child spinning a toy on a rope with an ant on the child's hand. As the ant climbs out along the rope, it starts to move faster and faster as it ascends. Compared to rockets, with cargo launched on an elevator, you only need to provide the energy to go up.
Now, see, an elevator like this, could this work? Probably. But it would be extremely fragile, I imagine. So, if anything hits that at any point, the entire thing would probably just collapse. So this is an extremely stupid idea.
Fast sideways movement comes free with the Earth's rotation. But a space elevator would, without a doubt, be the single largest and most expensive structure ever built by humans. So, is it worth it? It all comes down to costs. Rockets burn a huge amount of rocket fuel just to get a small amount of cargo into space. At current prices, it costs about $20,000 to put 1 kilogram of payload into space. That's $1.3 million for the average human.
Honestly, I don't think it could even be built, because the tallest building is the Burj Khalifa. I think that's how you say it. At what, 800 meters, I think. And to get to space, you would have to build. I need to check how much. Space starts at about 100 kilometers. The tallest building on Earth right now is 828 meters. Not even a whole kilometer. So you would have to build 100 Burj Khalifas on top of each other. Actually, no, that would only give you 8.28 kilometers. You'd have to build probably close to 130 of them. It just wouldn't happen.
$40 million for your car. Billions for an international space station. This immense cost is one of the major limitations of human spaceflight. Even with advancing technology, this cost isn't likely to be comparable with the price of an airline ticket anytime soon. A space elevator would solve this problem. After construction, a space elevator is projected to reduce the cost 100-fold to $200 per kilogram. If an inexpensive space elevator costs $20 billion, then we'll recoup our losses after launching only 1,000 tons, close to the weight of 2 international space stations. So what would a space elevator look like in real life? A space elevator has 4 major components: the tether, anchor, counterweight, and climber. The elevator part of the space elevator is the tether and the climber. It extends from the surface of the Earth to space. The climber is like a conventional elevator carriage.
I guess this would work, but I mean this tether would still have to be what, 100 kilometers at least. So good luck building something like that. the counterweight, it would have to orbit the Earth similar to how the moon does. Which actually makes me think, would this affect the Earth's oceans? Because the moon affects, what was it called? The moon affects the tides, I think? It affects water in some way. I don't know exactly how you said it. English is not my native language, okay? I don't remember everything. I imagine this could have a similar effect. Although actually, no, it probably wouldn't, because the moon would be way bigger and heavier. So no, this probably wouldn't have that much of an effect because it doesn't have enough mass. Well, anyway, this would be an orbit. And if this is constantly orbiting, although, it would have to rotate the same way that the Earth rotates to make sure it doesn't break the tether.
A chamber that works its way up and down the tether. At the base would be an anchor, pinning the tether to the Earth, along with a port for climbers. At the top is the counterweight, which holds up the tether. The tether is held tight like a rope and supported from above by the tension from the counterweight, located higher than 36,000 kilometers above the Earth's surface. At the counterweight,
how much?
Higher than 36,000 kilometers.
36,000 kilometers. I was talking about 100 kilometers. This is 360 times as much.
Above the Earth's surface.
Yeah, not happening.
At the counterweight could be a space station, a launching point for all missions from the spaceport elevator. But can we actually build one? It's hard to say. The biggest challenge is the tether. It needs to be light, affordable, and more stable than any material we can produce right now. There are promising materials.
And you need to produce enough material of it to make a 36,000 kilometer long tether. Like 36,000 kilometers. That's, I think, what it said, 3 times the diameter of the Earth. You wouldn't be able to find enough material for it, probably.
Materials like graphene and diamond nanothreads, but even they may not be strong enough. And aside from being incredibly strong, the tether would also have to withstand atmospheric corrosion, radiation, and micrometeorite and debris impact.
Exactly.
Additionally, it takes several days to climb the elevator. How do we power the climber? It requires a lot of energy to go
Solar
up.
energy, I would assume.
Do we need a nuclear reactor on our elevator carriage?
Or nuclear.
Or do we beam it power from the ground with a super-powered laser? And where do we get the raw materials for a 36,000 kilometer long tether? Do we make it on Earth and launch it into space, or do we make it in space and lower it down to the Earth? Could asteroid mining be the answer? Put simply, there are still some major technological hurdles to overcome. And a space elevator is not without risk. Should the tether break, it would collapse in spectacular style. If it breaks near the anchor, the force exerted by the counterweight will cause the entire elevator to rise up, ascending into space. Should it break near the counterweight, the tether will fall, wrapping around the world and whipping the end off. The resulting debris in orbit could pose serious problems to future spaceflight. If we build a space elevator on Earth, we have to do it right the first time. For these reasons, some experts have proposed first building a space elevator on the Moon. The Moon's gravity is much weaker than the Earth's, so a flimsier but existent material like
That actually sounds like a good plan.
Even with all these challenges, the payoff of having a working space elevator would be immense. It might be the first step to truly becoming a spacefaring civilization. Maybe we will never build a space elevator, but in trying to do so, we might learn an awful lot. And when it comes to the exploration of the universe, there can't be too many dreams of a glorious future.
Honestly, I highly doubt something like this could ever be built. Not because it's impossible, but just because humanity wastes too much time, energy, and resources on pointless things that do not matter in the long run. Look at the Ukraine and Russia situation right now. Is there any point in that? No. It's a waste of time, money, resources, and human lives. As is pretty much any conflict. For something like this to be built, it's just not going to happen because humanity humanity wastes too much time on pointless things like conflict, territory, shit like that. Just, you'd have to first unify all of humanity and basically just create world peace for something like this to be possible. And as pretty much everyone knows, world peace is impossible, which means this is also impossible. So yeah, like and subscribe, comment, link to my Discord server is down in the description below, so check that out if you want, and I will see you in the next video.